Okay, so as promised today, I will try to complete our syllabus with our fifth chapter for electronics lab. Okay, so I'm hoping that if we can finish it by today, so tomorrow I'll be giving you some tutorial exercises for you guys to try to do lah. Okay, and then we may proceed with our assessment. Okay, so the last topic is operational amplifier. Okay, so op-amp lah dia punya ni. I'm sure that you pun dah pernah dengar lah benda ni. Even kadang you kerja pun ada pakai kan. Okay, so kita tengok dia punya outline dia lah, topic outlines for chapter 5. So the first one is about the op-amp punya characteristics. And then number 2, the application of op-amp itself lah. So there are many applications which are available in terms of the usage of op-amp ni. Tapi saya ikut kepada kita punya CLP, Course Learning Plan, where we will be look into the summing amplifier, differential amplifier, comparator and Schmitt trigger amplifier. Yang itu sajalah. Okay, yang lain-lain dia ada macam-macam lagi. Dia ada macam-macam lagi application ni, saya tak sentuh lah. Okay, the way maksudnya kalau tak ada tu, kalau kita sentuh rugilah kan, kita akan waste a lot of time lah dekat situ. Okay, right. So we look into the introduction of op-amp. So op-amp is a very high gain amplifier with high input impedance and low output impedance. So dia punya input high impedance, output dia low impedance. It is one of the most important devices used in electronic equipment. So one of the most famous series is 741. So it is used extensively in filtering, perform mathematical operations such as add, subtract, integration and differentiation. Okay, so ini dia punya overall, dia punya the application lah. Nanti kita akan tengok yang detail nanti. So this is the symbol of op-amp. You have this one as the symbol and this is the circuit model. So you have the inverting and the non-inverting input. So that depends on the symbols of the input lah. Negative for inverting, positive for non-inverting. You have VCC and VCE as well as the output. Okay, so this is your inverting, non-inverting, this is your V out. Okay, so this is the circuit model which are available lah dalam bentuk IC. So it has two input terminals, inverting V1 and non-inverting V2 and output of V0. Requires two power supply, which is the plus VCC and negative VEE, and has a very high input impedance Z in, a very low output impedance Z out, and a very high gain. Okay, so amplify maksudnya dia menguatkan lah. So of course dia punya gain tu adalah tinggi. So what are the advantages of the usage of op-amp? So it is low cost, small size, versatility, flexibility and dependability. Okay, so that is the advantages lah. So maksudnya kalau kita tengok dia punya advantages ni memang is in the list of characteristics which are desirable lah. Okay, yang kita nak in terms of our electronic circuit. So kalau you ada features macam ni, maksudnya you adalah komponen yang bagus. So the characteristics for an ideal op-amp, it should have the following characteristics. Okay, but ini ideal ideal. So means that yang terbaik lah, where it should have infinite voltage gain AOL, bandwidth also infinite, input impedance also infinite, and then you have output impedance 0. Okay, so bila output impedance tu 0 means that your gain will be maximum. Zero offset voltage, the VOS, and then you have the CMRR infinite as well. So nanti kita tengoklah nanti apa benda CMRR, apa benda-benda ni lah. Infinite slew rate, okay, the S, and then no effect of temperature and 0 PSRR. Okay, so that is for ideal op-amp punya characteristics. Okay, so kita boleh tengok sini lah, Z in infinite, okay, Z out sama dengan 0. Gain dia adalah apa ni pun infinite juga. Okay, so that is for ideal. But a more practical op-amp which are easily for us to find lah, ini yang biasa kita jumpa lah, which has the following characteristics with a voltage gain of 20,000 to 200,000, bandwidth of 1 mHz, so it is limited lah, and input impedance up to 2 mega ohm, and output impedance is 75 ohm for low output impedance. Okay, so kita boleh compare lah, okay, dengan ideal dengan yang real world yang ada. Okay, so a typical op-amp is made up of 3 types of amplifier circuits, which is the differential amplifier, a voltage amplifier, and a push-pull amplifier. Okay, so kita ada differential, voltage dengan push-pull, amplifier output stage. So ini yang ada dekat dalam kita punya op-amp ni. The differential amplifier, which is this one, okay, the input stage ni, is the input stage for the op-amp which provides amplification of the difference voltage between the two inputs, the non-inverting dengan inverting input tadi. The second stage is usually a class A amplifier that provides additional gain, where some op-amps may have more than one voltage amplifier stage. So yang part ini depends, ada op-amp yang ada more than one. A push-pull class B amplifier is typically used for the output stage. Okay, so yang the last one, this one, push-pull. So this is the op-amp LM741, which is the most popular IC version. Okay, so ini kita tengok, this is the pin arrangement. So for your IC source 741, you'll be having 8 pins. Okay, and each of the pins tu ada dia punya own function lah, except for pin 8, which is there are no connections here, and then one for offset null, so tak ada connection untuk ni lah. Inverting input 2, non-inverting 3, the negative VEE 4, positive VCC is 7, output is 6. Okay, 5 pun offset null juga. Okay, so 5 of the pins are connected to the op-amp. So the pin diagram, pin 2 is the inverting input terminals, and pin 3 is the non-inverting input terminal. Pin 6 is the output, pin 4 is negative VEE, which is negative V, and pin 7 is 4 plus VCC. 1 and 5 are offset null pins, so these are used to nullify offset voltage. Pin 8 is a dummy pin and no connection is made to this pin. Okay, so tak ada function lah. So the input signals which are yang kita compare tu lah, yang non-inverting dengan inverting tu. So the input signal modes are determined by the differential amplifier input stage of the op-amp. So the differential mode is the one signal is applied to an input with the other input grounded, or two opposite polarity signals are applied to the inputs. So there are two ways. With single-ended differential mode, when an op-amp is operated in a single-ended differential mode, so one input is grounded and a signal voltage is applied to the other input. So kita boleh tengok sini lah. Okay, salah satu dia akan di connected to Vin, satu lagi dia akan groundkan. So when the signal voltage is applied to the inverting input, okay, which is this one, an inverted amplified signal voltage appears at the output. Okay, so dia inverted. Terbalik When the signal is applied to the non-inverting input with the inverting input grounded, which is this diagram here, a non-inverted amplified signal voltage appears at the output. Okay, so itu untuk single-ended differential mode. For double-ended differential mode with two opposite polarity out of phase. So kedua-duanya kalau kita tengok dia mempunyai phase yang berbeza lah. Satu bentuk positif negatif, satu lagi negatif ke positif. Signals are applied to the inputs. The amplified difference between the two inputs appears on the output. Okay, so equivalently, the double-ended differential mode can be represented by a single source connected between the two inputs. So sama je lah kalau kita pakai tak sama macam ni pun, which is this one kita pakai dua V-in yang berbeza, ini kita pakai V-in yang sama, tapi dia still akan jadi double-ended sebab satu akan masuk non-inverting, satu akan masuk pada inverting. Okay, so itu differential mode tadi, which is the first one, dia punya op-amp punya input modes. The second one is the common mode, where two signal voltages of the same phase, frequency and amplitude are applied to the two inputs. So when equal input signals are applied to both inputs, they tend to cancel, resulting in a zero output voltage. Okay, so kalau sama, then dia akan cancel lah. This section is called a common mode rejection, CMRR. So it's important, its importance lies in the situation when an unwanted signal appears commonly on both of these op-amp punya input. Kalau dia sama, okay. So CMRR ni, common mode rejection, means that this unwanted signal will not appear on the output and distort the desired signal. Okay, so output dia akan jadi 0 volt. The reason why, because the two input ni dia menerima same phase of V-in. So dia akan cancel out lah. Non-inverting dengan inverting punya input ni dia akan cancel out dia punya ni V-in tadi. Okay, then we look into the parameters lah, benda-benda yang kita discuss dekat sini tadi, karakteristik dia tadi. So now we look into the parameters. The open loop voltage gain for differential gain. So an op-amp amplifies the difference between the two input signal. So VD equivalent to V2 minus V1. So the open loop voltage gain of an op-amp is the internal voltage gain of the device and represents the ratio of the output voltage to input voltage when there are no external components. Okay, so that is for the open loop punya voltage gain. Common mode gain. So if V1 equivalent to V2, then ideally the output must be 0. So this one tadi lah. Okay. Okay. Sorry, this one common mode ni, yang ini sama. But practically, the output voltage not only depends on the difference voltage, but also depends on the average common level of the two inputs. So such a common level is called the common mode signal. The differential amplifiers produces the output voltage proportional to the common mode signal. Okay, so that is for common mode gain. So the CMRR ni, okay, common mode rejection ratio ni dia salah, saya salah type ni. The CMRR is the ability of an op-amp to reject a common mode signal. So benda yang berlaku dekat sini ni, bila V2 dengan V1 dia adalah sama, V-in dia adalah sama. So if the op-amp dia dapat reject, okay, the reject common mode signal ni, that is known as the common mode rejection ratio. So it is defined as the ratio of open loop voltage gain AOL to common mode gain ACM. So CMRR equivalent to AOL over ACM. So the higher the CMR, the better the op-amp. The high value of CMRR means that the open loop gain AOL is high and the common mode gain ACM is low. Okay, so atas lagi besar daripada yang bawah, so kita akan dapat nilai CMRR yang tinggi. Maximum output voltage swing, the VOPP. So with no input signal, the output of an op-amp is ideally 0 volt kalau tak ada input lah dekat inverting dengan inverting. So this is called the quiescent output voltage. When an input signal is applied, the ideal limits of the peak-to-peak signal are plus minus VCC. So in practice, however, this ideal can be approached but never reached. So the VOPP, which is the maximum voltage output voltage swing, varies with the load connected to the op-amp and increases directly with load resistance. So lagi tinggi resistance, and then nilai VOPP ni akan lagi meningkat. So dia berkadar langsung. Input offset voltage for an ideal op-amp produces 0 volts out for 0 volts in. So tak ada input masuk, output pun akan jadi kosong. So in a practical op-amp, a small DC voltage appears at the output when no differential input voltage is applied. Okay, itu practical op-amp yang standard ada yang kita pakai. So the input offset voltage, the VOS, is the differential DC voltage required between the two inputs to force the output to 0 volts. So typical values of input offset voltage are in the range of 2 millivolt or less. So in the ideal case, it is 0 volt lah. Okay, even in millivolt pun sebenarnya nilai dia dah kecil sangat dah tu. But of course saya cakap tadi untuk dapat ideal tu sangat susah lah. Okay, for input offset current, ideally the two input bias currents are equal and thus their difference is 0. So in a practical op-amp, however, the bias current are not exactly equal. So the input offset current, the IOS, is the difference of the input bias currents expressed as an absolute value input bias current, which is IOS equivalent to I1 minus I2. Okay, so depends kepada dia punya practical ataupun ideal op-amp. Input bias current. The input bias current is the average of the two input current of the op-amp. So it is calculated as follow. I bias equivalent to I1 plus I2 divided by 2. So it is the DC current required by the inputs of the amplifier to properly operate the first stage. Okay. The input impedance is the differential input impedance is the total of resistance between the inverting and non-inverting inputs. So which is the Zin. It is measured by determining the change in the bias current of a given change in differential output voltage. So kita akan menggunakan I bias ni punya pengiraan. The common mode input impedance is the resistance between each input and ground, and it is measured by determining the change in the bias current for the given change in common mode input voltage. Okay, so ini untuk the common mode, ini untuk differential mode. So input impedance ada dua condition lah. So input impedance untuk common mode ni dia ada resistance between each input. So dua-dua input inverting dan inverting tu ada dia punya resistance. Kalau differential tadi kita ada satu resistor sahaja untuk both input. So kita boleh dapat kita punya impedance. So the output impedance is the resistance viewed from the output terminal of the op-amp. So output terminal of the op-amp, the values which are obtained from the Vout, kita dapat dekat Vout sinilah. So berapa kita punya impedance dekat situ. Okay, so ini dia punya internal lah, how we get the Zout output impedance. Slew rate represent the maximum rate of change of a signal at any point in circuit delta V over delta T, voltage over time, perubahan masa dan bahagi perubahan waktu. Usually expressed in units of voltage per microsecond. So the limitation in slew rate capability can give rise to non-linear effects in electronic amplifier. So tadi kalau kita ingat slew rate ni dia punya ideal, kalau boleh kita nak infinite slew rate lah. Okay, so for ideal op-amp kita punya value untuk slew rate dia adalah infinite. Okay, so that is the parameters. So now we move on to the operation of the op-amp. So we have to understand lah. We have gone through the characteristics and then the parameters which are important, yang berkait dengan dia punya functionality lah. So now we look at how this op-amp operated lah. So it is basically differential amplifier which amplifies the difference between the two input signal. So this is an inverting amplifier This is non-inverting. Okay, so the difference is, look at where V1 is voltage is applied and yang mana kita groundkan lah. So this one is inverting. So the input is going to the negative input of negative input pin of the op-amp. This one dia akan masuk kat positif, yang negatif ni dia akan groundkan. So inverting, kalau kita punya signal mula-mula dari positif ke negatif, dan non-inverting dia akan terbalik lah. And obviously dia akan besarkan signal tu lah. Katakan sini 2 volt, sini mungkin jadi 10 volt. So dia punya gain adalah 5, contoh macam tu lah. But tengok dia punya signal tu out of phase lah, terbalik. If you applied for the non-inverting amplifier punya input, then you will get the same phase output, sama, okay, positif ke negatif. And dia punya value tu lagi tinggi lah. Okay, sebab because of amplification. Inverting amplifier. When voltage V1 is applied to the inverting input with the non-inverting input grounded, V2 equivalent to 0, which is this one tadi. Okay. The output voltages is equivalent to VO, equivalent to A V2 minus V1. So kita akan dapat V2 tu sama dengan kosong. So kosong tolak V1, so sama dengan AV1. So this indicates that the output voltage is amplified with the gain A and inverted. Okay, phase or polarity reverse with respect to the input voltage. Sebab tu kita dapat dia terbalik output dia. Inverting, when the voltage V2 is applied to the non-inverting input with the inverting input grounded. So V1 equivalent to 0. So V0 equivalent to A, V2 minus minus V1. So V2 tolak kosong, so kita dapat AV2. This indicates that the output voltage is amplified with gain A and it is the same phase of the polarity of the input voltage. So kita dapat phase yang sama. Okay, waveform, output waveform punya phase sama dengan input waveform. So there are assumptions that have to be made in terms of the operation of op-amp, where for zero input current, okay, so the first assumption is there are zero input current. Since the input resistance of an ideal op-amp is infinite, so no current flows into an op-amp. So this makes the input current zero. Okay, and then number 2, virtual ground. So for an ideal op-amp should have an infinite gain. So we know that the output voltage 0 volt equivalent to A V2 minus V1. That makes V2 minus V1 equivalent to VO divided with A. So if gain A is infinite, that means that the difference V2 minus V1 equivalent to 0 or V1 equivalent to V2. Okay, sebab kita groundkan dia punya output voltage. Okay, so these are the assumptions lah, ada dua. Zero input current and virtual ground. So this means that the input terminals of an op-amp are always at the same potential. Thus, if one terminal is grounded, then other one can be treated to be virtually grounded. Okay, so itu assumption yang memang kita kena buat lah. Okay, in terms of the operation of op-amp. Okay, now we look into the circuits of op-amp. We know the operation, macam mana dia punya operation or inverting dengan non-inverting input. Okay, which is this one lah, non-inverting dengan inverting. Now we look into the example of the circuits. Okay, so we look into the inverting amplifier lah. So where the Vin will be supplied into the negative input. So this amplifier produce a phase shift of 180 degrees between input and output. So from the circuit, the potential at node B, which is here, is 0 sebab kita connectkan dia kepada ground. From the concept of virtual ground, the two input terminals are at same potential. So therefore, the potential at node A, which is here, okay, node A ni sama dengan VA. VA tolak VB sama dengan kosong. So VA sama dengan VB. Okay, sama macam ni tadilah. This one, persamaan yang virtual ground ni tadi. Okay, so this is the circuit diagram. If you look at it, kita ada R1, kita ada RF for the feedback. Okay, dia punya nama dia ni apa nama dia, feedback bukan feedback loop. Okay, kalau dekat sini ada dia punya resistor. So this one is grounded. So B and A, the VA and VB will be having the same value lah. Okay. So from the circuit, we can find that I1 is equivalent to V in over R1 and IF equivalent to minus VO over RF. So atas ni dia punya derivation, bahawa saya terus ambil dia punya output je lah, dia punya persamaan je lah. Okay. So since op-amp input is 0, input current is 0. So I1 passes through RF and IF. That is IF equivalent to I1 equivalent to IF. So V in over R1 sama dengan negative V0 over RF. So V0 equivalent to negative RF over R1 darabkan dengan V in. So here this value here of RF over R1 is called the gain of the amplifier, and negative sign indicates that the output is inverted. Okay, so samalah macam sini tadi pun kita dapat negatif A V1 untuk inverting. Okay, so maksud dia sekarang negatif 2 indicates that dia adalah inverting dan output dia adalah terbalik. So ada terangkan dekat sini lah. Okay, so dia punya gain adalah RF over R1. So this is the input and output waveform of an inverting amplifier. So we'll be having different phase of signal. This is positive, output is negative. Okay, and then this is negative, this becomes positive. Okay, so the value of the voltage differed lah. Ni just nak tunjuk dia punya bentuk waveform sahaja. For non-inverting amplifier, so this amplifier amplifies the input without producing any phase shift between the input and output. So whatever phase you applied on the input, that will also be the phase for the output. So from the circuit, the potential at node B, which is VB, which is here, equivalent to V in. Okay, so from the concept of V to ground, the two input terminals are at the same potential. So therefore, the potential at node A here equivalent to VB lah. So VA sama dengan VB sama dengan V in. Alright, so this is the circuit. Kita boleh tengok dia punya connections. Sama je, cuma bezanya dekat mana dia punya input dia lah. So from the circuit, we can obtain that I1 is equivalent to V in over R1 and IF equivalent to VO minus V in over RF. Okay, so since the op-amp input current is 0, so IF will passes through RF and I1. That is, so this is the equation lah. Okay, so kita tengok, we will get VO equivalent to 1 plus RF over R1 darabkan dengan V in. So 1 plus RF over R1 is the gain of the amplifier. And then compared dari tadi ada negatif. Okay, dekat sini tak ada negatif. So tak ada negatif, maksudnya dia tidak berubah fasa, berubah phase. So dia tetap pada phase yang sama. So this is the waveform lah. So kita dapat the first one daripada kosong naik kepada V maximum, balik kepada kosong, turun kepada negatif V. Ini pun sama lah. But the value of the voltage will be different lah, because amplifies, so dia akan jadi lagi tinggi. So there are no phase shift between the input and the output waveform for a non-inverting amplifier. Okay, that's for the characteristics of op-amp lah. So kita tengok the introduction, basic characteristics and the parameters as well as the operation. And then tadi kita tengok dia punya circuits for inverting dengan non-inverting. Okay, so adalah rumus-rumus di sini. Okay, so that is about the characteristics. Now we move on to the dia punya application of the op-amp. So tadi ada 4 yang kita akan tengok. So kita akan tengoklah satu-satu. The first one is op-amp as an summing amplifier. So by using op-amp to become summing amplifier, dia ada 2 ke 3 jenis, tapi saya buat 2 je, inverting dengan non-inverting. Dia ada satu lagi yang ada 3 input tu. Adder summing amplifier tu saya tak sentuh lah yang tu. Okay, so inverting summing amplifier, adder the input signals to be added are applied to the inverting input terminal. So kita tengok sini kita ada tambah nilai voltage yang berbeza kepada inverting input. The non-inverting still connected to the ground lah. Okay, sebab ini inverting So the potential at node B, which is here, VB sama dengan kosong sebab grounded. So from the concept of virtual ground, the two input terminals are at same potential, which is B and A. Therefore, the potential at node A, VA equivalent to VB, which is also equivalent to 0. So from the circuit, we obtain that I1 equivalent to V1 over R1, I2 V2 over R2, IF V0 negative V0 over RF. So kita boleh dapat dari sini lah. V1 over I1 for V1 over R1 for I1, V2 over R2 for I2. So kita dah dapat nilai I ni, kita boleh gunakan nilai, kita boleh guna Kirchhoff's law lah, VIR tu kan. So just terbalikkan dia saja. Since op-amp's input current is 0, so I1 and I2 together passes through RF and IF. So kita akan dapat V0 sama dengan minus RF over R1 darabkan dengan V1 plus RF over R2 darabkan dengan V2. Okay, minus ni for inverting. So if R1 equivalent to R2 and equivalent to R, so kita akan dapat V0 dia. This is the equation. So kita gantikanlah nilai R1 ni dekat dalam persamaan ni. If R1 equivalent to R2 equivalent to RF, so kita akan dapat this as the equation. So this shows that the output is the sum of the input signals. The negative sign indicates that the phase is inverted. So both condition untuk nilai R1 dengan R2 sama dengan nilai R pun ada negatif. Kalau R1, R2 sama dengan RF pun sama juga, ada negatif. So R1 dengan R2 either sama dengan nilai R ataupun sama dengan nilai RF. Okay, so that is for inverting. Kita tengok non-inverting pula. Kita terbalikkan lah. Non-inverting input pula yang sekarang kita ada dua adder input of V1 dengan V2. The inverting input tu kita connectkan kepada kepada ground. So the input signals to be added are applied to the non-inverting input terminals. So the potential at node B is equivalent to VB. Dekat sini dia adalah VB. So from the concept of virtual ground, which is the assumption yang kita boleh buat, the two input terminals are at the same potential. Therefore, at node A, VA is equivalent to VB. Apa VB tu sama dengan Vin tadi lah. Okay. Okay, node B sama dengan VB. So sini sama dengan VB. So VA pun akan jadi sama dengan VB. So from the circuit, I1 equivalent to V1 minus VB over R1, I2 sama dengan V2 tolak VB over R2. So ada different potential dekat situ lah. Okay, since the op-amp input current is 0, so VB equivalent to R2 V1 plus R1 V2 over R1 plus R2. So at node A, I equivalent to VA over R sama dengan VB over R, di mana VA sama dengan VB. So at IF, okay, dekat dia punya feedback tu, VO minus VA over RF, so sama dengan VO minus VB over RF. Okay, so sama sebab kita tahu dekat node kedua-dua A dan B, VA adalah sama dengan VB. Now, since op-amp's input current is 0, so VO equivalent to VB, R plus RF over R. Okay, so VO sama dengan R2 darabkan dengan R plus RF over R darabkan dengan R1 plus R2 sama dengan R. Oh ni kat dalam ni sebenarnya ni, dua dia ni dia kat luar pula. Darabkan dengan V1 plus R1 R plus RF and R over R darabkan dengan R1 plus R2 darabkan dengan V2. So if R1 dengan R2 equivalent to R, kita akan dapat V out dia, rumus dia yang ini. Kalau sama dengan RF, so V0 equivalent to V plus V2, V1 plus V2. Okay, so this shows that the output is the sum of the input signal. So kita boleh dapat nilai dia untuk output dia sama dengan jumlah input signal dia, V1 dengan V2 berapa. Okay, so that I think ni adalah rumus-rumus yang berkaitan lah yang you perlu tahu yang you akan guna nanti untuk you punya lab. Yang mana saya ada sentuh dalam ni lah, dalam nota ni. Okay. So number 2, the application of difference amplifier. So the output is the differentiation of the input signal. Perbezaan antara input signal. So the potential at node B, which is here, is equivalent to 0 sebab grounded. So from the concept of virtual ground, the two input terminals are at the same potential, where VA equivalent to VB equivalent to 0. So from the circuit, I1 equivalent to C1 dV in over dt, IF equivalent to negative V0 over RF. So the current is 0, so it will pass through RF and IF. So kita akan dapat V out equivalent to negative RF C1 over dV per dt in. Okay, dekat sini ada differential lah, dV over dt. So this shows that the output in the differentiation of the input voltage. So the term negative RF C1 indicates the gain of the amplifier. So ini adalah kita punya gain. Okay, so, okay, sebab tu nama dia difference amplifier, differentiation. Okay, this one perkataan ni. Next one, application of op-amp as comparator, where the amplitude of one voltage is compared with another. So tadi kita compare apa? Kita compare dia punya differentiation of the input voltage. Now kita compare dia punya voltage punya amplitude. So in this application, op-amp is used in the open loop configuration with the input voltage on one input and reference voltage on the other. Okay, so satu input voltage, satu reference voltage, V2 dengan V3. So here V2 equivalent to Vin and V1 equivalent to 0. Okay, so V2 equivalent to Vin, V1 equivalent to 0. Oh, ni V1 rupanya saya nampak macam 3. Okay. When Vin is greater than V1, which is 0, so V0 equivalent to plus V saturate, which is lebih kurang atau sama dengan plus VCC. Kalau Vin is lesser than V1, which is equivalent to 0, so V out maksudnya dia pada nilai negatif lah. Okay, sebab dia lebih kecil daripada kosong. So negatif V saturate ataupun lebih kurang sama dengan negatif VEE. So this is the waveform of the comparator. Okay, so the comparator circuit is also known as zero crossing detector. So circuit dia tadi lah, yang ni. The IC dan dia punya circuit. Okay, so it is the same phase. Kalau kita tengok dekat sini, dia sama. It is at the same phase lah. Sama dia punya input dengan dia punya output. Last one, op-amp application with the Schmitt trigger circuit, which is also called a regenerative comparator circuit. So the circuit is designed with a positive feedback and hence will have a regenerative action which will make the output switch levels. Okay, so the use of positive voltage feedback instead of a negative feedback aids the feedback voltage to the input voltage instead of opposing it. Okay, dia akan membantu bila kita gunakan positive voltage instead of guna negative feedback. So the use of a regenerative circuit is to remove the difficulties in a zero crossing detector circuit due to low frequency signals and input noise voltages. So this is the circuit lah kalau kita tengok. Okay, so kita tak menggunakan feedback. Kita gunakan, jadi dia ada terang dekat sini, kita gunakan voltage, positive voltage feedback instead of negative voltage feedback. Okay, so masuk kepada dia punya inverting. Okay, it is basically an inverting comparator circuit with a positive feedback. Okay, so the purpose of the Schmitt trigger is to convert any regular or irregular shape input waveform into a square wave output voltage or pulse. Thus, it can also be called as squaring circuit. So mostly used to convert a very slowly varying input voltage into an output having abruptly varying waveform occurring precisely at certain predetermined value of input voltage. Okay, so kita guna application op-amp ni biasanya untuk ni lah, untuk convert kalau dia punya varying input voltage tu to convert very slow, yang mana dia punya nilai dia punya varying dia tu sangat slow, input and output having abruptly varying, maksudnya kita nak ubah dia punya waveform tu menjadi lebih laju dan lebih tepat lah. Okay, so input tadi tu adalah predetermined lah, berapa yang kita nak masukkan. Okay, so input and output waveform of Schmitt trigger. So kita ada kat sini, daripada sine wave kita akan dapat square wave at the same time. So dia punya transition from 0 to 1, and then 1 to 0, 0 to negative, then back to positive pun sama lah. Okay, so this is predetermined lah. Kita dah tahu, kita dah letak berapa nilai dia apa semua. So kita akan dapat dia punya nilai V set positif dan V set negatif. Okay, so that is the 4 application of op-amp which are listed in the topics of the chapter 5 lah. Okay, so summing, difference, amplifier, comparator and Schmitt trigger. Kita ada lagi ada macam-macam lagi sebenarnya. Okay, tapi tak payah lagi kita tengok sebab tak bayar, tak ada, so kita tak payah tengok lah. Okay, so that's it for our syllabus. We have covered all of the topics which are supposed to be covered by us. Okay. Okay, so I think that's it for our lecture session. Okay, so tomorrow's night kita akan buat tutorial session, dan juga saya akan hand out to all of you your assessment, your lab report. Okay, so you have lebih kurang 2 minggu lebih sikit lah untuk you, 3 minggu lah lebih kurang untuk you complete your assessment. Okay, so ada 5 lab report tu, banyak juga sebenarnya, tapi they are simple report sajalah, bukan report macam final year project kan, just a assessment report, so tak perlu panjang-panjang. Just look into yang saya share semalam tu kan, ada marking rubrics, tengok marking rubrics tu, so macam mana you nak tackle dia punya tu, kat introduction what you have to do, dekat discussion, result and discussion, what do you have to discuss about your report and everything. So itu esok malam lah saya akan bagi. Okay, do you guys have any question? Ada soalan ke?
Tak ada, sir.
Tak ada. Okay, sekejap saya share attendance .
So, assessment tu macam mana?
Assessment esok malam, saya akan bincang esok malam. Saya ingat nak bagi malam ni, tapi belum dapat lagi saya nak cakap pun belum dapat yang ada verification. Belum dapat yang ada verification. So saya takut nak bagi yang kosong macam tu je kan. Saya tunjuk sikit lah . Assessment. Oh, okay. So you are required to prepare a report, answer all questions in English language only. Okay, so memang you kena buat report lah sebenarnya. Tapi dalam report tu you kena buat macam ni, circuit, measure, okay, dapatkan nilai-nilai ni, masukkan dalam report lah. Okay, so I'm planning that this assessment to be done in groups lah. Cuma itulah saya check dulu ada berapa orang. Sekarang ada pula yang tak ada partner. Saya rasa ada 9 orang ni. Okay, ada 9. Ada 9 9 students. So kalau nak buat 3 nanti macam apa pula. Saya ingat tak apalah, buat 2. So look for your partners lah. Okay, boleh buat berdua for this lab report. So ada satu group tu saya benarkan untuk ada 3. So 2, 2, 2, 3 lah. Okay, so bukan personal punya ni lah, buat berdua, buat in groups lah dia punya assessment tu. So tak apa, itu nanti saya share sebab harap-harap boleh dapat lah by esok. Saya pun tak tahulah, saya hantar dah lama dah tapi saya nak dapat balik daripada diorang tu lambat betul. Dah 2-3 kali dah saya dah pesan kan, kata saya nak pakai dah ni, tapi itulah busy sangat kot, saya pun tak tahu lah. Okay, so please scan your attendance guys.
Sir, saya tak dapat nak scan lah, sir.
Tak apa, nanti bagi nama.
Okay.
Yang tak boleh scan nanti bagi nama. Yang boleh scan, scan dulu. Okay, siapa yang tak boleh scan?
Muhammad Azham, sir.
Okay.
Bisa.
Hidayat ada ke? Hidayat tak ada hari ni.
Fitri, sir.
Okay, Fitri ada. Okay guys. Ada soalan ke? Ada soalan nak tanya? Kalau tak ada soalan, then I think I'll end the session here. So starting esok kita dah start boleh buat tutorial sikit, kita boleh buat assessment dah, saya dah boleh bagi semua assessment lah untuk you all buatlah slow-slow kan, kita buat untuk submission nanti. Okay, so I think I'll end the session here. InsyaAllah tomorrow night kita jumpa sekejap untuk saya hand overkan assessment dan juga soalan-soalan tutorial lah with the solution for you. Okay, thank you guys. Assalamualaikum and good evening.
Waalaikumsalam, sir. Thank you.
Okay.
Assalamualaikum.
Thank you, sir.
Alright.